Okay, Assalamualaikum class. So let's move to the second part of chapter 9. How you're going to compare between two sinusoids. So this sinusoid can be either sine or cosine. So you are going to compare between one sinusoid that is V1 to another sinusoid that is V2, and we'll see how it goes to the concept of lead or lag. So before that, let's recall back what is sinusoid. So this is a sine wave. So this is the amplitude and this is the angular frequency. So how you relate the angular to the cyclic frequency? That is 2 pi f. What is f? It's actually 1 cycle per second, per time, right? Per time. So you got here f equal 1 over t. So let's say here you have two signal. One is V1, another one is V2. So there's come the concept of lead or lag. So how are you going to see which one is lead or lag? You look at the x-axis, that is the time. So this is in the omega, the angular frequency multiplied by time. So it says here pi and 2 pi, right? So 2 pi means, so let's recall back, here is 0. Let's say this is 90, 270 and 360. So 0 here is, says 180, this is 270, and here is also 360, right? So this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, so pi means what? Pi means 180, this one is 360. So what is the period here is 2 pi. From where it starts to repeat itself, from point here and point here is t is equal to 2 pi. So now let's compare between V1 and V2. Which one is leading, which one is lagging? So you look at this V2, this dotted line here, right? This is V2 and this one is V1. So which one comes earlier? Which one comes earlier is V2. So V2 leads what? Leads V1 by what? So you need to see the difference of the distance of the location between V2 and V1. So it leads by phi. That is the phasing. Okay, so we can call that V1 and V2 is actually not in phase, it is out of phase. So how can we compare? We need to make sure both sinusoid need to have a same frequency. What does it mean by frequency? It's actually 5 sine. So let's say the frequency here is 2t plus 30, and V2 also we have 5 sine 2t minus 40. So you need to make sure the frequency of both signal V1 and V2, the angular frequency, this is the omega, right? And this is also the omega, need to be the same. Then you can compare. Okay? If the phase difference is 0, means they are in phase. So let's say here we don't have plus 0 and here is also plus 0. So means this signal is overlap each other, right? So we call this one in phase. But when the phi of phase different, the one at WT plus for phi here are not 0, they are out of phase. Okay. So in order for us to make sure both are the same frequency and also the same, if V1 is sine, V2 need to be sine. But if V2 is a cosine, you need to change to sine. So you need to be able to know how to change from sine to cosine. So how you change from sine to cosine, how to change from cos to minus cos, sine to cos, and cos to sine. So this is the formula, but in your electric circuits, let's try to use the graphical approach. So let's say here is cosine and here is sine. So this is need to be opposite, and this one is also minus sign. Okay, so you are given a function v1t is equal 5 cos omega t plus 30. how you're going to this one to change to sine. Just 5 sine omega t plus 30. So what is the number here? Okay, so in order for you to do that, what you need to do, so this is sine, this is cosine. You're going to change this cosine to sine, right? So you look at here, so where is sine and where is the cosine? So your intention is you're going to change this signal to cosine. Okay, you're going to change the signal to cosine. Means your arrow here is going up. The initial is cosine, right? So you're going to change from sine to cosine. So if it is a anti-clockwise, it is negative. If it is a clockwise, if it is a clockwise, is negative. If anti-clockwise is positive. So this one is positive, right? So this is 0, this is 90, this is 180, this is 270, right? So from here to here, so this one you need to be plus 90. Okay, so you can get your V1t is equal to 5 sine omega t plus 120. So this is how you change from cosine to sine by adding 90. So let's change this one back to cosine. Okay, now your function is sine. You're going to change to cosine omega t plus 120. And what is the function here? Okay, so we do the inverse. Okay, now let's see. I change the color. Okay, so this is another one. So you want to change this sign to cosine. So now, how you're going to change your cosine to sine means you're here cosine to sine. So when cosine to sine, it need to be negative. But negative, what is the angle here? Negative 90. So the function here is minus 90, and then you can get here 5 cosine omega t plus 30. So it will be the same with before. Okay, so means when you want to change cosine to sine, you are adding by 90. You're going to change sine to cosine minus 90. So cosine to sine 90, right? And then here is our going to change from sine to cosine is minus 90. So you don't need to remember this one. Just focus on this graph. Okay, so this is the explanation. So your graph here is just now cosine, sine, minus cosine, minus sine. So if it is clockwise, it should be negative. If it is anti-clockwise, it is positive. Clockwise is negative. Okay, so become anti-clockwise, it will be positive. Okay. Okay, so let's see this first example. So tips number 1, when you are comparing two signals, the sinusoid need to be in the same form. This is rule number 1. So you can see here one is minus cosine, another one is sine. So usually we make practice to convert everything to become sine. Second one, you need to check the frequency need to be the same. So here is the frequency is omega, the second one is also omega. Yes, it is the same. And then we can compare. First step, change minus cos to what we call sine. Now let's redraw back. Here is cosine, this is sine. Here is minus cos, here is minus sine. So you are going to change this minus cos to what our function here is 10, you are going to change to sine, right? Because you want to compare WT plus 50. Okay, what is the number here? So if you look at this part, okay, so this is sine. This is sine, right? So you're going to change sine here to become cosine. So look at the direction, sine here to become minus cos. Sine here to become minus cos. So this is 90. But is it plus or minus? So if this is clockwise, is minus. If this anti-clockwise, is positive. So if you look here, this is clockwise. So clockwise means negative. Okay, so you can get here V1 10 sine omega t minus 40. So this is the one that you need to compare between V2, that is 12, sine omega t minus 10. Okay, so how you're going to compare these two graphs? Okay, first, you need to change because you want to know the phase, the phi, right? So just equate the bracket to become 0. So WT1 is equal to 40. How about number 2? WT minus 10 is equal to 0. WT2 is equal to 10 degree. So this will be phi 1, this will be phi 2. Okay, next you plot the graph. This is the first step. Then you start to compare the phi. And number 3, you plot the graph. Okay, let's say we are going to plot the V1. So what is the phi here is 40. So you just make it here, and the amplitude here is 10. So let me change the color of the pen. Okay, how about phi 2 is 10. And the amplitude here is 12. So just make it another one. Okay. Now what we need to do? We want to see which one is leading, which one is lagging, right? So this one is V2. So V1 just now is this one. Okay, now how are you going to see which one is leading, which one is lagging? So looking from this figure, which one is leading? V2 leads V1, right? Because V2 reached first. By how many phi? So you can hear the distance between the V2 and V1 here is 30. So by 30 degree. Okay. So first step, always check it is in the same form and convert everything to sine. And then you check the frequency will be the same. And then first you convert everything to sine. And then you check what is the WT1 and WT2, and then you plot the graph, and then you can see which one is leading and which one is lagging.